Welcome to this video on topic 5, where we explore comparison and box plots, turning raw numbers into visual stories. This video follows the data analyst pipeline, moving from organizing and visualizing data to describing it, ultimately leading to comparing and interpreting through box plots. As you can see from the slide, there are two classes here, Class A and Class B. When evaluating performance, like comparing two classes on a test, one single number is rarely enough. We must look at the mean, median, spread, consistency, and shape. To extract a core summary, we identify the 5-number summary: the minimum, the first quartile, the median, the third quartile, and the maximum. Next, we calculate the interquartile range to define the middle 50% of the data and use fences to check for potential outliers. Well, you see, a box plot visually represents this 5-number summary, creating a geometric architecture of the data spread. Alright, moving on. Let's apply this to the Sabah COVID-19 case study. We need to determine which phase was more severe and more volatile. Remember, the box plot is built upon these 5 critical values: the minimum, the first quartile, the median, the third quartile, and the maximum. Follow these 8 steps in your workflow, from arranging raw data to plotting the final box plot for a reliable summary. As you can see here, before doing anything, you must arrange your raw data first, either in ascending or descending order. After that, you can find your median, Q1, Q3, calculating IQR, and check for fences and outlier. Let us considering the data from COVID cases. A few data we consider it as phase 1 data. For phase 1 of our analysis from 12 until 18 of March, we start by sorting the raw data to easily identify the median, quartiles, and range. As you can see here, the raw data are 1, 14, 11, 23, 8, 25, 21, and the summary are as shown in the box below. Calculating the spread shows an IQR of 15. Checking our fences confirms that there are no outliers in this dataset. When constructing the blueprint, ensure your axis is properly scaled to avoid distorting the distances between values. Here is the completed box plot for phase 1. You can see clearly your median, Q1, Q3, as well as the minimum and maximum values. And the spread too. Now let's see the skewness. Skewness describes the asymmetry of a distribution, whether it is symmetric, right skewed, or left skewed. If symmetric, the left and right side tail should be equal. If not, it must be right or left skewed. If you see the right tail tends to be longer, then it is right skewed. If it's longer on the left side, then it is left skewed. This slide also shows clearly the skewness of our box plot, plotted in graph form. Let's compare the information from these two phases. As you can see from the table, we have phase 1 and phase 2. This is the box plot of the two phases just now. Phase 1 and phase 2. Can you spot the differences? We may plot both phases to see the differences clearly. You might notice phase 1 center is higher, while phase 2 appears right skewed. One tips for you all, use the CMSS framework: center, middle spread, overall spread, and shape. This helps you compare any two datasets systematically. How do you do your conclusion? Please take note on what not to say as shown in this slide. When applying the CMSS framework, you will be explaining the conclusion in detail and correct. Okay, now, let's go back to our COVID-19 cases data. By October 7, 2020, Sabah cases urges to 282 cases in a single day. So if we draw a normal whisker out to 282, the box plot becomes unreadable, as you can see here. Alright class, remember to practice these steps with different datasets. Visual evidence, while powerful, should always be supported by your calculated statistics.
Okay, so overall, there are 5 questions to ask when you see a box plot. Number 1 is, where is the median? The median is the points to the center. Number 2, how wide is the box? Your IQR. Number 3 is how long are the whiskers? It points to the overall spread. Number 4, are there isolated dots? Number 5, which side is visible longer? It decides your skewness of the data. So as for conclusion, look at the story, not just the box, because good data analysis is not just calculating numbers, it median explaining what the numbers mean. So I hope topic 5 are all clear. Don't forget to do the assessment. Good luck and goodbye all.